Hi guys, in this video I'm going to talk about how to do the preliminary dataset assessment using Pandas in Python. Pandas is a standard Python library for working with datasets and for performing data analysis. It is such an important step, the entire data preprocessing, because like ultimately if your data is not good, then the output that your model is gonna give is also going to be like really trash, right? So you have to spend you have to put in a lot of time and care to make sure that your data set is actually clean. And what do I mean by a clean data set? A clean data set actually means that you have addressed the missing values. Maybe the type of the data is like consistent. In the case of qualitative features, maybe you need to perform categorical encoding, which basically means replacing the string values. Maybe it's a yes no thing. Maybe you need to replace the string values with numbers like 0 1 and stuff like that, right? Because ultimately when you push in the data set into a machine learning model, which is usually a mathematical model, right? The model is gonna mess up if you push in a string value, right? So you need to take care of that, and there is a plethora of steps that falls under the category of data preprocessing, which actually makes up most of the process, right? Most of the time in the entire process. Anyways, so I don't know what I can cover within the scope of this video, but I'll try to talk about some of the steps. Maybe not cleaning part, because I want to have a separate video dedicated to just cleaning the dataset. But like the preliminary assessment, what I mean by preliminary assessment is just like looking at the dataset, inspecting different things using pandas, and then maybe like try to answer some questions that we might have, some presumptions that we might have of the dataset. Maybe we want to look at whether we can try to locate a certain trends. Anyways, let's see what we can do in this video. I'll have the timestamps in the description, so if you want to like skip ahead and move to different parts of the video, feel free to do that. Okay, so I'm here in the documentation of pandas. So the first thing it tells you is that you need to have pandas installed, right? So I already have pandas installed because I have the anaconda installed. Pandas does not come with the standard Python distribution. The standard Python distribution does not come with pandas modules. So if you have that, then you have to manually install pandas. Otherwise, if you have anaconda, then you should be good to go. It is going to tell you the different things that you can expect to do with pandas. So for example, here, if you look at it, it tells you that Pandas imagines the dataset in the form of a data frame. Data frame is exactly like if you open a file in an Excel, Microsoft Excel, then you can see that it's in the form of a table where you have columns on the top and then you have rows on the sides, right? So data frame is just like that. We're gonna look at that, and while it installs, let me go ahead and go to Kaggle and find a dataset that we can use for this tutorial. So if you don't know what Kaggle is like the mecca for data science people. People are participating in competitions every week. They're talking about their models, how well their model performed, different steps to optimize their models, and different steps to like they're introducing new things every day to make sure that the best practices and stuff like that. So I would highly encourage that if you're into data science and machine learning, that you spend a lot of time in Kaggle. Kaggle also happens to be like a really great place to find data sets. But one thing that you need to understand though is, the data sets that you find in Kaggle are like a very neat and organized. But like in real world, uh, more often than not, you will not find datasets that are that clean, right? So for example, if you have like different sensors in place that are collecting different type of information from an environment, then sometimes you will see that your sensor has failed to register in a certain value. So then you have to address missing values, right? Or maybe the data type is not consistent, and there could be so many problems that you need to take care of if you want to make sure that your model performs at its gives you the optimal performance, right? Anyways, so I went ahead and found a dataset that I think is like a really good dataset for this particular illustration. So before we download that, I want to show you that it's a CSV format. So CSV basically means comma separated value. The values are separated by comma, right? You also have datasets in the format XLSX, right? Then you also have it in the form of dot data, right? And then you can like go and see, look at the description of the dataset. You can see that it has 8 columns or features, right? You can call them columns are actually called features, right? Then it does it tell how many observations there are? No worries, we can find that later on. So I have actually downloaded the dataset and I've put it neatly into a folder. I'm going to include the link to that dataset so that you can do the same if you want. You can, if you have the dataset downloaded, then you can, like, it will be easier for you to follow along this video, right? So okay, so my Anaconda prompt tells me that the Pandas library is installed, so that's awesome. So now what I need to do is I need to quickly go inside the folder, then desktop, then projects. Okay, awesome. So now I'm inside the folder where I have the dataset downloaded. So what I'm going to do is I'm going to run the Jupyter Lab, right? So Jupyter Lab is the more advanced version, like the next iteration of the Jupyter Notebook. Jupyter Lab has like a very neat interface where it shows you like the different files that you have in the directory. I absolutely love using Jupyter Notebook, but if you have Anaconda, then you will already have Jupyter Lab installed in your machine. But anyways, if you don't want to use Jupyter Notebook or Jupyter Lab, then you can still follow along this video by using Sublime or other editor like Atom, Spider, and stuff like that, or PyCharm even. Anyways, let me just create a notebook really quick. Sorry, not console. Okay. Awesome. So now I'm inside the folder where I have the dataset, the students performance dataset CSV file in the same folder. So now let me just, I can start writing the code, right? Okay, so let me import the library. So if I say import pandas, and then what I can do is I can assign an alias to the pandas library. Let's call it PD, which is the common convention. So now PD basically means pandas here. So now PD recognizes everything that pandas has to offer. PD recognizes all the functions that are in pandas. So I don't have to invoke. So if I want to call a function that is in the pandas library, I don't have to invoke pandas again. I can just say PD, right? So anyways, how do we the first thing that we have to do is how do we import the file? So what we can do is we can say PD dot, and then one really cool thing about notebook is that if you now hit tab after you type dot, then it's gonna give you the list of functions that are in the pandas library. So if I say the function that we need here is something called read CSV, right? So what we want to pass as the parameter is the name of the dataset, right? So the name of the dataset is students performance, right? Okay, and what we can do is we can put it inside a variable. Let's call it df. Df basically stands for data frame. That's the convention. You can call your variable whatever you want. Okay, so now if I want to just quickly print df, now it gives you a neat representation of the dataset that we have here. You can actually see that it has 1000 observations, right? And 8 columns. Awesome. You can read the columns on the top. You can read the labels as the rows. Okay, and then what we can usually what is usually done is you can use something called head, which basically gives you certain number of values, some certain number of rows from the top. So if I say df.head and then maybe 10, so it's gonna give us the 10 observations from the top, right? So yeah, and then similarly, if you want observations from the bottom of the dataset, we can say df.tail, and maybe we want like 20 observations from the bottom, right? So yeah, so that's pretty neat. Now if we say df.shape, so it tells us that it has 1000 rows and 8 columns, right? So we can do that. Before we go on and try to locate a particular cell, we need to first understand the difference between LOC and iloc, right? So LOC basically means location and iloc basically means index location. So what does it even mean, right? So LOC basically tries to find the position of a value based on the label, and iloc basically tries to find the position of a value based on the index. And labels are these things, right? And index is something that is inherent, right? Like for example, this is something like 00 and stuff like that, right? 01, 02. Indexes are like that, right? It's an inherent thing, but labels are the ones that you have in the sites. Now coincidentally, the labels here are in the form of the index. So in most cases, for this particular example, LOC and ILOC will behave in the same way, but there is a major difference, right? For example, instead of this as the labels on the rows, if we had strings, then it would have behaved differently. So in the case of LOC, we would have to mention those labels in order to access those cell values, and in case of ILOC, we just have to mention the index values. In although we just have the uh, although we have the labels in the form of index, I would still like to show you the difference between LOC versus ILOC, because I think that it's very important. Sometimes, like when you come across a pandas file, sometimes you'll see that people are using LOC and sometimes people are using ILOC. So I want you to understand the difference, right? So let me just go ahead and like show you the difference. So for example, if I say LOC 1, right, it's gonna give us the values in the first label, right? So one label, so the gender is female, race ethnicity is group C, and so on and so forth, right? Similarly, if I say ILOC1, it should give us the same values, right? But interestingly enough, if we do this, if we say ILOC and then maybe 1 if we do it with LOC, it should give us an error. And the reason why it gives an error is because it understands 1 as the label for the rows, but it does not understand 1 as the column, right? Because yeah, it doesn't understand because the column labels are not 1 2 3 4 5. So now you can clearly see the difference between LOC and ILOC, right? But if in the case of ILOC, it recognizes 1 as the index for the row and it recognizes 1 as the index for the column. So if I now run the code, it gives us ILOC group C, right? So the same thing, if we needed to access using LOC, we would have to say LOC then 1 is the label for the row, as you can see here, and 01 we need to see the label for the column is race ethnicity, right? So instead of 1 we have to say race ethnicity, right? And we get the same value, right? So that is the major difference between ILOC and LOC. ILOC, you find the cell value using the index, and LOC you find the cell value using the label, right? Okay, so that is something that we need to know. Now if so, as you can see that the first value, like there are two values that we're passing, right, separated by a comma. So the first value basically stands for the rows and the second value stands for the columns. So now if you wanted to say maybe print the so maybe we wanted to print the 50th value, 50th value, like for the gender. If you want to check the gender of the 50th student, so we can do that, right? So if we run the code, it's showing that the 50th, we can't see here, but I'm assuming it's right. So the 50th, not the 50th because it starts from 0, but the label which is 50, for the student, the label for which is 50, the gender of that student is male, right? So we can do that, and this is how we can locate certain cells, right? Now for example, if we wanted to, okay, so we just saw that how to find out a specific cell value using LOC, right? What we can do is we can do something like this. So here are the two values that you need to pass. If you want to pass in, if you want to say that print all the rows, what we can do is we can pass in column, right? And if you say that I want you to print all the rows of the column math score, then what you need to say is this, right? Math score. and then it should give us all the rows of the math score. Fair enough. And now this is how we select certain cells. This is how you can like print different columns. Now maybe what we want to do is let me just go ahead and see what is inside, what is in the data set, so that I can make more. Okay, so maybe for example, if we look at the data set, we can see that there is gender, race, ethnicity, parental level of education. I felt that the data set is like really interesting, and we can do many things with the data set. But like for example, if you look at this particular column, it says test preparation course. Maybe if we decide that the this column is not going to add value to our analysis, what we can do is we can drop the column for a certain analysis. We can say that and this is what is going to allow us to perform analysis by not including certain columns, because maybe we feel that that particular the values of that particular column is not going to add value to the analysis. So what we can do is we can say df dot drop, and then what we can do is we can say test preparation course, and then I think we need to pass in another do we need to pass in? Maybe not. Okay, so if I run the code, okay, we need to, okay, so it says we need to we need to pass in axis as well. So what does axis mean? Axis basically means, axis takes in two values. So 0 value basically means rows and 1 value means column, right? So it's either 0 or it's 1. So 1, we want to drop this particular column, so we're going to pass in axis equals to 1. So if you run the code, so now if you look at this, it's going to show you that the test preparation course has been dropped from this particular data frame. But and like we can maybe store it in a variable, let's call it burgers, whatever, doesn't make sense. But and now if I call burgers, it's gonna give us the data frame without the test preparation course, because we have just dropped it, right? But what you need to understand though, that the column has not been permanently deleted from the data set. So for example, if you just go ahead and print df data frame, the original data frame, then you're going to see that the column is still there. Test preparation course column is still there, right? So it's just like for certain analysis, if you want to drop certain columns, then you can do that using this, right? So that is about dropping columns. What we can do now is we can sort values of a certain cell. So maybe there is math score, there's a reading score. So this values, also the string values can also be sorted based on like alphabetically categorized. But like maybe we want to like sort the math score, maybe we want to look at all the student observations. We want to look at observations starting from the person who got, like here, like the ascending sort will mean that the math score is the least, and the descending sort is going to mean that the math score is the highest, right? Anyways, this is self-explanatory. So what we can do is we can say df dot, okay, so I hit tab, sort values. All right, so what I can do is I can say give me all the math score, like give me all the data where, and like sort it based on the math score, and I want you to sort it using, like maybe if you want to do it ascending. So what we do is there is a parameter, sort values function takes in a parameter called ascending, and ascending basically is a boolean. It takes in a boolean. So for example, if you pass in true, then it's gonna do the sorting ascending in an ascending order. And if you want to sort it in a descending order, then you just have to say that ascending is equal to false, right? Just passing the false boolean value, and then it's gonna do the descending sort. That is, you don't have to explicitly mention descending anywhere, right? So we can say true, right? And then if we run the code now, so the math score is like from the lowest to the highest, right? The similar thing, if you want to do descending sort, we can just say false, and now the math score is the highest, and so on, and it reaches the lowest, right? So yeah, that's pretty interesting, something that we can do here. So now what I wanted to show is that these are very fundamental things that we may want to do to inspect the data set that we have going on. So now if I just go ahead and like look at the data set again. Okay, so now maybe what we want to do is we want to find out all the students who got certain scores in math or reading or writing. Like, so how do we do that? So what we can do is we can introduce conditions, conditional statements, right? If else condition, if you remember Python scripts, you can have like if else. So you can also do that here. Maybe not like, you don't have to necessarily explicitly mention if else, but like similar to that, you can have like conditional statements. So what we can do is we can say def, and then this is the primary third bracket, and then we can have like a lot of brackets inside this primary bracket, right? So what we can say is that we want you to find all the math score, just give me all the math score which is greater than maybe 50. Okay, maybe greater than 50. So now all we have all the math scores or values that are that is above 50. And similarly, if we say that no, just give me all the student values, so all the students who got less than 50 marks, right, in maths. So now we are just getting we're just getting all the observations, all the students information who got less than 50 in maths, right? Now if we just wanted to find the genders, if we just wanted to look at the gender, like how many people got less than 50 marks, we can just, what we can do is we can say gender here. If we run the code, so now we can get an idea of like the gender, but it's not going to add any value. I think we need to make it more clear. So let me just go back and run. So this is one condition, right? It's a very simple condition. We just told the told our system, told our script that give me all the students who got less than 50 marks, right? So now what we can do is we can also introduce certain conditions. We can add conditions, right? So if you want to do a lot of conditions inside, so what we can do is we can put it inside a bracket, first bracket, and then what we can do is we can tell that, okay, I want you to obey this particular condition. I want you to fulfill this particular condition, and I want you to find me all the students who got reading score less than 50 as well, right? So now if I go ahead and run the code, it's going to give me all the people who got both math score less than 50 and reading score less than 50. So yeah, this is something that you can see. So now if I furthermore, if I say I also want you to give me all the students who not only got less than 15 maths, not less than 15 reading, but also less than 15 writing, right? So we can do that also. We're just passing more conditions, right? So these are the students, like just like quickly, if we just, a simple condition is just telling so much about the data set, right? So these are the students who got less than 50 in both math, reading and writing, right? Because we said and instead of and we can also say or, right? So somebody who got okay, so now if we just wanted to quickly do one thing, if we want to say like all the students who got greater than 50 or greater than 80, let's make it more interesting. Let's see, greater than 80 in all the three tests. Let's see if there are students, right? And now maybe we want to find out whether if the gender has any correlation with students getting higher marks in all these exams. So if you want to find out all, just like if you want to say that fulfill this particular condition and then just give me the genders, right, of the students who got high marks in all of these exams, right? We can say genders here in a separate gender, not genders, okay? And then we can see that, there's a lot of females, and then like there's a lot of female, right? But like in between we are not getting, so like it's like 110, right, the length. Anyways, so there are some things that you can like run, and different things that you can see. Maybe if you want to find out whether the parental level of education has any correlation with people, with students getting higher marks or lower marks, you can do all sorts of different things. You can write in different conditions, and then maybe you can like export this to a graph, and then express your observation and your results in the form of a graph that you can use using matplotlib. I have matplotlib videos in graphs, like in my channel. I have made how you can like plot graphs in matplotlib using seaborn previously in my channel. If you want to look at that, you can do that. But like if you want me to make more graphs using like data frames and stuff like that, please let me know in the comments. And this is more or less what I wanted to show you, like the preliminary assessment. The next thing would be maybe like if you have like certain assumptions that you want to test, you can do that here. But like or if otherwise, like the next step would be to find out whether if there are any missing values that you want to address. And like maybe there are, like if you can see that there are categorical values here in the lunch column. So maybe we want to perform the categorical encoding, maybe we want to convert them to 0, 1 and stuff. Anyways, we talked about dropping columns, we talked about sorting values. Like there are different ways by which you can like look at the values. Like I talked about how you can select certain columns, how you can select combination of columns. Didn't I talk about selecting combinations of column? So for example, if you just want to see maybe maybe gender and math score. Sorry, give dot lock. Use LOC for finding out the different um, things that you wanna find out. What am I missing? Oh, I'm just like mentioning the columns, right? So I should mention all the um, so like in addition to that, like if I wanna like mention, give me all the rows of gender and math score. Have I showed that already? Okay, whatever. So like I can get like multiple columns, and then like run, and like I can like do all those like preliminary assessments, right? So that is more or less what I wanted to show in this video. In the next video, I would like to perhaps cover like how to clean the data in a more extensive way. Here like you are also cleaning data to some extent, like by dropping columns and stuff, like just making the analysis more clear, the data more to the point. But anyways, that's more or less what I wanted to talk about in this video, and see you guys next time. Bye.